I'm going to present the work, A Method for Feasibility Evaluation of Food Waste Treatment Technologies in Small Urban Centers, by Rodrigo Urban, Ivan Turtera, both from PUC Campinas, and me, Liane Nakada, from Unicamp. Food waste is different from other organic waste, as it has a high content of organic matter, moisture, salts, and oils. Also, it has a low carbon-nitrogen ratio and a high concentration of easily degradable organic substance. For that reason, common composting methods may not be suitable for the treatment of food waste. The aim of this study was to develop a method to assist waste managers in the selection of food waste treatment technologies for small urban centers. The methodology applied to this study consists in developing a flowchart for selecting a composting technique and then testing the selected technique in a pilot scale unit. The method was applied to assess the technical feasibility of implementing vermicomposting for the treatment of food waste generated by a food court at a university campus. The study was developed using solid waste produced in the food court called Service Area 1 of Campus 1 of PUC Campinas. Service Area 1 comprises 3 restaurants, 4 snack bars, 2 kiosks serving juices and popcorn, 6 service stores, in addition to space for students and employees to store their homemade food. Classes take place in the morning, afternoon, and evening, being the latter with the largest contingent of users. Service Area 1 represents well food courts in large educational institutions. Now, I'm going to present the flowchart proposed in this work. The flowchart stages comprise definition of treatment criteria, selection of treatment technology, gravimetric evaluation of food waste, proposal for the use of byproducts, assembly and operation of the pilot scale unit, evaluation of treatment, and evaluation of byproducts. The first step was the definition of treatment criteria. The main criteria were composting time and simple assays for treatment evaluation. The second step was the selection of treatment technology. We selected vermicomposting because it produces a good quality compost in a shorter time than other composting methods. We conducted a gravimetric evaluation of the waste from food waste collectors, and the results of this step are shown in this graph. As you can see, only 54% of the waste in food waste collectors were food waste. Following the gravimetric evaluation, we found a problem. 46% of the waste was non-food waste, but packing materials, such as paper, 18%, and plastic, 24%. In step 4, we propose the use of the compost to control erosion in degraded areas. In step 5, we assembled the composting unit using food waste, wood shavings, soil, and earthworms from the species Urubenus brasiliensis. Here's a picture of the vermicomposting unit, and here's a figure showing how it was assembled. So, on the bottom we have a container to collect the leachate, and containers 2 and 3 are the containers for the food waste and the composting process. So, first we have a layer of wood shavings, then soil, then food waste, and then the earthworms Urubenus brasiliensis, followed by another layer of wood shavings. We observed that degradation of food waste occurred in a reduced decomposting time, only 24 days. but it was not possible to evaluate the quality of the compost and the stability of the organic matter with the predefined assays, which were pH, total solids, moisture, and electric conductivity. The compost did not present aggregation behavior in geotechnical Atterberg tests. After the evaluation of the treatment and the compost, we concluded that new criteria are needed for treatment selection. The possible implementation of a full-scale treatment without the application of the described method would not be successful, causing economic losses to the institution and non-acceptance of the proposed treatment. The authors thank PUC Campinas and CNPq for the scholarships, Turtera. And here's an email if anyone has any questions. Thank you for your attention.